Welcome to Monochemistry. Today we're going to look at a weak base equilibrium problem. And here it is. The pH of a 1.00 molar solution of the weak base methylamine is 12.3. The equation for the reaction of methylamine in water is as follows. What is the Kb for methylamine? So step 1 for a weak base, just like with a weak acid problem, is to write the dissociation, or in this case the reaction of the weak base, with water. As you can see, this is our Bronsted-Lowry base, and this is our Bronsted-Lowry acid. This is our conjugate acid, and this is our conjugate base. But step 1, regardless of what you've been given as a base, weak base in this case, is to write a balanced equation as follows. The next step is to create an ice table. And we're going to fill in some of the information from the ice table. This is 1.00. This is 0, and this is 0. Remember, unless otherwise stated, the amount of the products at the outset of the reaction is going to be 0. The methylamine is going to lose X as it reacts with the water, and these other guys over here, the ions, are going to gain X. The value of these at equilibrium is going to be X, and this is going to be 1.00 minus X. Okay, so remember, this is what we're solving for, Kb. We've been given 1.00 molar solution, and we've also been given the pH. Okay, but the Kb is what we're solving for, so let's follow through with that. So we start by writing the expression for the Kb. The Kb in this case is going to be equal to the concentration of the CH3NH3 plus times the concentration of the OH minus divided by the concentration of the methylamine, as given in the reaction on in the question. Now, if I substitute the values from the ice table in, I should have X times X divided by 1.00 minus X. But unfortunately, I don't know what X is, so in order to solve for Kb, to get the final answer, I need to solve for X. But what is X? How do I find it? Well, let's look at the other information that I was given. For starters, I was given the pH. I know that the pH is equal to minus the log of the H plus concentration. Therefore, the H plus concentration equals 10 to the minus pH. So in this case, the H plus concentration is going to be equal to 10 to the negative 12.3. But I can solve for that, but H plus, if you look back at the reaction, there is no H plus. I need an OH minus, not an H plus. Then I start to think. I remember that the concentration of H plus times the concentration of OH minus always equals 1.0 times 10 to the negative 14. Based on that information, if I know the H plus concentration, then I can solve for the OH minus concentration. So that's exactly what we're going to do right now. We're going to go ahead and we're going to plug in the information to solve for the H plus concentration. Then we're going to use the equation at the bottom right here. Rearrange it, and we're going to solve for the OH minus concentration. I'm going to go ahead and put my values in. You guys try it on your own. The value for the H plus concentration is 5.01 times 10 to the negative 13. And the OH minus concentration is equal to 0.0200. Okay, so now that we know the value of the OH minus concentration, let's see where that leads us. Recall from the ice table that the concentration of OH minus at equilibrium is also equal to X, which of course is also equal to the CH3NH3 plus concentration. So now that we know the value of X, we can actually go ahead and solve for our Kb. Our Kb would be as follows. .020 squared divided by 1.00 minus 0.0200. And when we plug those numbers in and solve for Kb, we get 4.08 times 10 to the negative 4. Remember, the Kb value has no units, but that is how you solve it. So you start off, you got a bunch of information from the question, you have to kind of figure out where to go, but in this particular case, you start by figuring out the OH minus concentration. Once you know the OH minus concentration, which is also equal to X, you can solve for the Kb. And that in a nutshell is how to solve these weak base equilibrium problems. Make sure you bring your questions to class.